Hi again. I'm Chris Bowers, and my office is upstairs. If you go into the courtyard and go up the stairs, you'll turn left and go all the way to the end of the hall, and you'll find my office. And I hope to see you there whenever you need help this semester. Please feel free. My office hours are on your syllabus, and the office number is SM279. I am recording this for my online students to be able to watch, but online students, remember, things might be a little different than, for example, testing. You're watching me with an actual class, and they will be testing in the classroom while you will be testing at the testing center. So I wanted to start out just give you a little bit of information about myself. I've been teaching here this is my 6th year full-time, but I've done adjuncting for TCC for many years. I was at FSU full-time for 7 years before that. And so when I first came over, students said, why are you going to TCC? Well, because I love TCC, and I love TCC students. I love being able to teach and get to know you and help you as you go along. And at FSU, everything was large lecture, and I loved it there too, but it was just a different kind of teaching experience, so I like it a lot better here. My husband and I have been married since graduate school, and we have 3 children. The first 2 are married, and so yeah, I'm an old lady, but I've got a lot of energy still. I keep exercising and keeping in shape for my grandchildren. We also have 4 dogs. So if you're a dog lover, then I have that in common with you. 2 of them are large breed puppies, and they about drove me crazy this morning, but they're fun. Our daughter, who's our 3rd child, is a senior this year at a local high school. So that's just a little bit about me, and I wanted to see if you guys have any questions about the syllabus, and I also wanted to look on Canvas with you and look at how the homework works. I think that you probably all got my email. If you haven't, look in Outlook. That's the only time unless Canvas is down or something, that's the only time I email through Outlook is before Monday of this week, because you can't access the students through Canvas email until classes begin. So now I'll email you through Canvas. Do you guys have any questions in general before I show you homework and show you the modules and what's there? Does anybody have any particular questions about anything? I asked you to read the highlighted portions. Okay, I'm going to talk about late passes. Now, if you just had 1033, this is going to be real similar to what you did there. But what we're looking at here are modules. And if you go to my home page, I've got it in the module choice of a home page, but if you click on syllabus, then you'll find the actual syllabus and your schedule, but you'll also be able to see what homework and quizzes or whatever else is due on a particular date. So remember, that's that syllabus link. It makes it real easy, and of course you guys get reminders, I think, as well. Okay, make sure you get in this in the next couple days and do this how to enter answers, because if you don't start an assignment, I can't add your late passes. I'm going to talk about what late passes are in case you haven't had those before. But make sure you at least get started on that how to enter answers in the next couple days. Okay, so when you do an assignment, now I picked one, let me go down here a little bit. I went ahead and made this one past due so I could show you something. All right, first of all, everybody gets 10 late passes, and that's a lot. I gave a lot because that way I don't ever have to think about it or worry about you or anything. If you get the flu or whatever, hopefully nobody will, but if you do, then you've got these 10 late passes that you can use. You do need to understand how they work, though. They're only for the online assignments. They work for quizzes, and they also work for homework. But they're only good for 4 days past the due date. After that, you'll never be able to get credit for that assignment again. It will be in review mode. This one, well, I don't see usually we've got a red thing that says in review mode. No scores will be saved. If you ever see that, guess what? No scores will be saved. So you can use it to practice if you need to do some extra practice, but it won't count as anything. Now, if you want to redeem a late pass, though, remember it's got to be within 4 days of the due dates, which mostly for you guys are going to be on Sundays, okay? Just to make it simple. I try to do it on Sundays. Every now and then it'll be a little different depending on when a test is or something. I might have to schedule a little differently, so don't always count on Sunday, but that's going to be our regular way of working. But if you just click on this, redeem late pass, and what happens, you'll hit OK, and then you'll hit yes, I want to use that late pass, and then you just work on the assignment. And you have until 11:59 p.m. on a Thursday if it was due on a Sunday. Okay? Does anybody have a question about that? Yes?
Do practice quizzes count towards our grade?
I don't have practice quizzes. I have quizzes in there, and they do count towards your grade. I think 1033, I think we had practice quizzes, yes. Now, I do have 3 test reviews that are extra credit, and so that we don't do information overload, we'll talk about that closer to the time, okay, and how those work. Another thing you can use is messages. Every now and then there's a bug in a problem, and that actually happened last semester in my 1105 class. There was a question, I think it's in the first assignment too, where something wasn't working. So if you think that something's not working, let me know. But I want to reassure you that that is very rare because we have been working with this same program for several semesters now. We've gotten all the kinks out. But I think sometimes something just kind of sneaks in there. Okay? But you can use that message link to say, hey, would you do this one in class? And I'm happy to do problems at the beginning of class. Okay? Or if you have just some kind of quick question, you're at home trying to do your homework, because I have online classes, I tend to check on this several times a day. So that way you could get your question answered a little quicker maybe. Okay? Does anybody have any questions about anything else? We've got 3 tests and a final. We've got homework. We've got quizzes. We've got something later in the semester called the QEP. And that's about it. So I do want to warn you that for some people, this first unit is challenging. And I think that's because you didn't quite learn what you're supposed to in 1033. If you did a good job in 1033, you're solid, okay? Because you're not going to feel lost when you see me doing factoring review today. So I want you to hear me about this. If today you feel challenged, very challenged, or lost in any way, let's get on top of it this week. Do not put it off, all right? Come see me. Use the Learning Commons. You guys have 30-minute conferences that are free to you at the Learning Commons. Also in Canvas, there's a link on the left-hand side called Smart Thinking. Every TCC student has access to a certain number of minutes in Smart Thinking, and it's live tutoring at home. Okay? So that, of course, you guys see me twice a week, so you may not need to use that as much as my online students. But remember, it's there if you want to use it. Okay? And so don't let ourselves get lost this first week. If you're having trouble, come see me. Another thing that's considered review in the first unit, but may not feel like review to you, is the work we do with lines. You did a lot of work if you took 1033. You did a lot of work with lines. And so we don't spend a whole lot of time on them, but you still got to know them. We're trying to prepare a lot of you to take calculus. So it's very important that we, never let ourselves feel lost, that you get the help that you need whenever you need it. Okay, so all that said, unless somebody's got a question, is there anything hanging out there that I need to think about? Yes, sir.
When is the latest when you get
Oh, good question. February 3rd. Okay, I think our first test, does anybody have it in front of them, the schedule possibly? Let's double check. You'll want it on the first test, but it's It's February 8th, so you would want to have it by then. Okay? And does anybody know at the Learning Commons, do they have ones that you can just use while you're there? That's something I would think they would have, but I mean, you got to make sure you know how to use it. So, and I would look around and see if you can find a used one as well. If you're going to take all your math at TCC, and you keep going after 1105, you're going to do pre-calc algebra, pre-calc trig, maybe calculus. You'll need that calculator the whole time. So make sure you have a TI 83 or 84. Yes, sir.
And then will that 5 days before the semester starts and 5 days after the semester starts, the bookstore will let you use your financial aid to get whatever you want.
Thank you. That's good information to have. Okay, so it sounds like you can go ahead and get it.
By the end of this week,
Yes, I would go ahead because you're going to see me start showing you how to use it. And the Learning Commons produced videos that show you how to use the graphing calculator. I've got a link at the top of the Canvas page. Okay, so if you're ever having trouble with it, look at that. It's kind of a blessing and a curse, the graphing calculator, because I don't want to spend a lot of time in class learning how to use the calculator because we've got to work on the actual material. I do go through the steps. I do let everybody practice, but then I expect you to learn it. So if you are still having trouble, then come see me. Because there are some things you will have to do on the graphing calculator. There's no way around it. Okay, yes?
Which one's better, 83 or 84?
It doesn't matter. It doesn't matter. Anybody else? Okay. Well, I'm excited to get started with you guys and you online students. So we're going to do some review here. And I do have, has anybody looked at my videos by chance? You haven't really had time. They are posted in Module R. I've got review of factoring videos. So we're going to kind of just, this is just review right now, but if you need to go back over something, I do have those posted in Canvas. Okay, so remember in factoring, you should always, always, always look for the GCF first. And this is the thing that's going to be kind of a place where students get messed up in the first homework assignment. Hey, remember what I'm doing right now is I'm just reviewing factoring, but in a little while what we're going to do is we're going to use factoring method to solve equations, which is different. So this is just part of that process. So what I'm doing is I'm looking at the numbers 2 and 32, and I see that 2 goes into both of them. So that's part of the greatest common factor that we're going to factor out. So we're going to put a 2. And then we see that we have the variable t in common. Here we have t to the 6th power. Here we have t to the 4th power. So what they have in common is 4 factors of t. So we factor out the t to the 4th. Now, how many terms did I have? 2. So when I factor out the GCF, how many terms should I have in the parentheses? 2. It's never 0. Sometimes people think if they factor the whole thing out, there's 0 left. No, it's a 1 that's left. It's very easy to get confused between 0 and 1. Okay, so t squared times t to the 4th gives me back the t to the 6th. And there's a minus there, so I'm putting minus since I had a positive GCF. And 16 times 2 is what would give me the 32. I factored the entire t to the 4th out. Okay, now this factors again, right? And we haven't reviewed that yet, but let's go ahead and have it so we have it in our notes. We will see the formula in just a minute. But that is called a difference of squares pattern. It's when you have a minus, not a plus. This is prime. If it was a plus, it's prime. It does not factor. Okay? But if there's a minus, and both of these are perfect squares, then you have the difference of squares pattern to use. So this is t to the 4th times t plus 4 times t minus 4. And we'll talk about why that works in a minute. Okay. So the next thing we're going to look at are these factoring patterns. This one's called difference of squares. That has to be a minus. not a plus. And if you have a difference of perfect squares, then it'll factor as a plus b, a minus b. If you use FOIL, does everybody remember FOIL for multiply it out? Okay. If you use FOIL, it's easy to see why that works. Yes, it cancels. The O and the I cancel because A times A, that's where we get the A squared. The outer product is an A times a negative B, so I'm going to write that as product minus AB. The inner product is a positive B times A, so I'll write that as plus AB. And then the last is a plus B times a minus B, so that is minus B squared. And so these two add up to 0, and that's why that works, because you get A squared minus B squared. So even though we multiplied two binomials together, we did not end up with 3 terms, we ended up with 2. It's very important that you focus on that. Okay, now this next pattern is one that throws people off all the time. It is called a perfect square trinomial, and we're going to be using this a lot this semester. We're going to be working with something that is related to the perfect square trinomial called completing the square. So it's really important that you don't just go through the motions and do your homework and think you're doing enough, okay? Come back to these notes and look at them, because a squared plus 2ab plus b squared factors as a plus b times itself, which is not the same as the last thing. And we don't write it that way because it's the same thing twice. We write it as a plus b squared. And that is a binomial squared. So notice, if you do have a binomial that is squared, it doesn't give you 2 terms back, it gives you 3. And I want to encourage you guys, because of time, I'm not going to do it right now, at home, multiply these together, and you're going to see where the 2ab comes from. All right? And I'm going to show you in just a minute how to recognize that you have a perfect square trinomial, because it won't quite look like this. If there's a minus, now notice we still have the plus here, okay? But if there's a minus, see, compare those two, everybody. See, the only difference is the plus here and the minus there. The only difference is this will be a minus b squared. Okay? So those are the factoring patterns that you need to know so well that you don't make mistakes. So let's look at some more. So we're going to recognize the patterns now. All right, we have 2 terms. We have a minus in between. We have 2 perfect squares. Everybody see it? It's a difference of squares. Okay? So that means it's going to be 5x plus 3 times 5x minus 3. 5 times 5 gives me the 25, and 3 times 3 gives me the 9. And then x times x gives me x squared. Okay, now, when you get into your homework, some of the problems are going to look a little daunting, okay, because the numbers are going to be larger than what you're used to in 1033. You can do it, guys. You can do it. You just have to remember a few things. First of all, when you have a trinomial, if you see large numbers, first of all, look for the GCF, okay? Second thing, though, is see if maybe it's a perfect square trinomial. Now, it can be if these 2 terms, and I've got it in descending order, okay? But if the first and the last terms are both positive, you've got to have a plus here, not a minus, okay? But they're both positive, and they're perfect squares. And if your middle term is even, it doesn't guarantee that you have a perfect square trinomial, but there's probably about a 95% chance that it is. So let's try it. This, if it is a perfect square trinomial, remember that means it's the same factor twice. Exact same factor. This is not exactly the same, right? This one had a plus and a minus. But the same factor twice, 3x plus 2, or not the same factor, but actually I do mean same factor. Sorry. Thank you. You caught my minus 2. Should be a minus 2. And 3x minus 2. Okay? That's the same factor twice. And the reason he was pointing out to me the minus is because the middle was a minus. Now, let's just check it real quick. And I'm only going to check the O and the I in FOIL because you guys can do the rest in your head, right? 3x is correct. Okay? -2, -2, everybody see? That's definitely going to give me the plus 4. The place where that middle comes from is the O plus the I. So that's what I'm going to check, is the outer product and the inner product. So the outer product is a -2 times a 3x. So that would be -6x. And the inner product is a -2 times a 3x. So that's -6x. And so that checks out. That worked. Everybody see it? Okay. So remember to look for patterns first. So GCF, then patterns. All right. The next thing we're going to review is factoring by grouping. So I'm purposely giving us one that needs to be rearranged first. Okay, 8t squared plus 2t minus 2t to the third minus 8. This is 4 terms. In this class, if you have 4 terms, it's probably going to factor by grouping. Is it guaranteed? No. Just because there's 4 terms does not mean it always factors by grouping. Okay? But I'm going to rearrange it. So I've got 2t to the third plus 8t to the second plus 2t minus 8. And then the way factoring by grouping works is you have 2 layers. Yes, sir. I'm sorry.
Why do you read it?
Oh, good question. Because it will probably work out better if I do that. And so I want to have it in descending order first. Yeah, sometimes we just don't have it in the right order to be able to factor. So you do that first. Good question. All right, so did you guys hear what I said a minute ago? There's going to be 2 layers of GCF. 2. And I want to see them both. Because I'm afraid a lot of times what I see students doing is they get into the homework, and by the way, I didn't mention the way the homework works is you have 3 tries on a problem. If you don't get it, first of all, you need help, okay? If you get it wrong that many times, that's a problem you need to go get some help on. But you can try a similar problem. You can still get the credit up to the due date, okay? Quizzes are not like that. Quizzes are going to be 2 tries per problem, period, because they're supposed to be a quiz. So don't take them until you're ready, all right? And maybe use the first attempt and then go, I thought I knew how to do this. That's when you can ask for some help, okay, as long as you start early. Okay, so we're going to look at this in 2 pieces here. So I am kind of ignoring the last 2 terms at first, and I'm just focusing on these 2, and I'm going to factor out the greatest common factor. Now, if the leading term is negative, I don't like that. It makes it very hard to factor. So I'm going to not only factor out the GCF, but I'm going to make it a negative to take care of that. So I'm going to factor out a -2t to the second because they have 2 in common and they have t to the second power in common. So you guys help me fill in the second set of parentheses, or the parentheses rather. What should I put in as the placeholder here? Yes, good. Everybody see why? Now, this was a plus. I pulled out a minus. So what do I need? -4. Good. -4. Check it. -2 times -4 gives me the +8. Okay? Now, once you do the first two, you've got a hint on the second two, because the whole thing is going to fall apart if we don't get this exact same factor. So we already know what we want. We want to have a t minus 4 over here. That's going to be the whole point. What is it that these two have in common? 2. So let's see. 2 times t, check. 2 times negative 4, check. So it does. This one is going to factor by grouping because I was able to factor out the same factor for those two groups. Okay, everybody see it now? And do you see what I mean by we're going to do GCF twice? Because those two groups, see the plus in between? This is a product, this is a product. We've got a plus in between. So you look at them separately and you say, do they have similar factors? And they do. They have t minus 4 in common. So what we do then is GCF again. We're going to factor that common factor out once, not twice, right? You just pull out what they have in common, which is the t minus 4. And then what do you put in the second set of parentheses? Good. So, very good. So we got negative 2t squared plus 2. Now, the thing about factoring is I'm going to say you almost always, it depends on what you're using factoring for, but you almost always have to look and see, does it factor again after you've got your product. How do I know it's factored? Because I can tell you that's a factor. T minus 4 is a factor of the whole thing. And negative 2t squared plus 2 is a factor of the whole thing. So it is factored. However, what do y'all see here? Yeah, you can pull out a 2 or a negative 2, either one. And again, it depends on what you're doing with the factoring, which way you want to go on that. Let's just pull out a negative 2. Now, some of you might have pulled that out at the beginning, and that would have been fine. But don't forget it's in your answer, at the negative 2. There's a lot of times in algebra there's more than one way to do your steps. So if you were thinking at the beginning, why didn't you just pull out negative 2? You could have done that, okay? But it's in your answer. Okay, and then I'm going to have t squared minus 1. Oh gosh, what's happening now? That's a difference of squares. See it? 2 terms, a minus, 1 is perfect square. So we actually have one more step. T minus 4. Just because of convention, I'm going to put the negative 2 at the front. That's usually what we do with a constant factor. We put it at the beginning. It's not wrong if you don't, but I'm going to do it that way. So I just put it at the front. And then t squared minus 1 factors is t plus 1, t minus 1. Now, finally, we have a product. You can tell me what all the factors are. And they are all prime. They don't reduce anymore. All right, now, this next part is where I hope you're not going to get mad at me, okay? There are students sitting here who learned to factor trinomials by trial and error. Who are you? Okay, I've got some like that. There are students who learn to factor trinomials by something called the AC method. Okay, see? Now, what I did in my factoring videos is I showed you the AC method. The AC method I like personally because it always works. However, it does take a little bit of time to learn it. So I don't want to mess up your factoring. Whatever way, if you're good at factoring trinomials, you should stick with what you know. Okay? You should just keep doing it. If you learned by trial and error, you should do trial and error. If you learned by AC method, then you're good. However, I know I've got some of you sitting here right now who never really got the factoring trinomials. Am I right? Okay. AC method will work for you. So what I think I'll do is I'll show it to you once here, but remember I've got that video. Those of you that learn by trial and error, you don't need to do it this way. You do not have to do it this way. You can do it the way you're used to. All right, and actually some of these are so easy that probably everybody would just do, sort of look at it and tell me how these factor. So we'll do that with the ones that seem a little easier. If the leading term is a 1, for example, then those aren't so bad, right? Because you can just go, all right, I know I need S times S. And then I've got to get the correct factors of negative 28 that are going to give me this negative 3S in the middle, right? 4 and 7. Are people seeing it? Okay. Now, you got to get your signs right. Don't forget to check. If I put the minus here and the plus here, let's check. Okay. We're going to do chin and grin. O and the I. Okay. Chin and grin to check. So out here we've got negative 7S. In here we've got positive 4S. That did give me the correct middle. So we're done with that one. Oh, let me add in a page. All right, let's do another one. Oh, I'm sorry. Sure. And for the students that are watching this online, I don't like the way this thing is following me around. I feel like it needs to just stay over here. Let me see if I can make it stay. That'd be better. Let's try that. I'll adjust it if I need to. Are we done with this one? Okay. All right. So let's look at another one. Do I have people who would like to see the AC method demonstrated? Okay, all right. The thing you need to understand about the AC method is that you're going to use factoring by grouping. So you have to learn to do that. Remember, and what it is it's going in reverse of FOIL. So let me kind of show you backwards what's happening so you can follow when we actually try to factor something. So let me take this problem. Okay. For some reason, it's still following me. I don't know why it's doing that. Okay. So let's look. This is going to be the correct factoring. All right. But I wanted you to see from the ground up what's happening. So let's use FOIL. Okay. So using FOIL, we've got 5v times v. That would be 5v squared. The outer product would give me negative 5v. The inner product would be plus 2v. And then 2 times negative 1 is negative 2. Okay? The O and the I are always like terms when you have factors that are linear like that, where you've got a variable term and a constant term for both of them, and it's the same variable. So when they add up, or rather the O and the I are going to be like terms, and that adds up to negative 3v. Okay? So when you use what's called the AC method, the reason it's called AC method, and you may as well get used to this, is we're looking at quadratic. Okay? Quadratic is something we do in Unit 2, second degree, you might remember from 1033. But when you write a quadratic expression in standard form, you'll have a times x squared plus b times x plus c. And so the AC method comes from these two numbers, the a and the c. That's why it's called that. Okay, so this is the way it works. We multiply the a and the c together. And so in this case, AC is negative 10. A times C is negative 10. Okay? Now, what we want are factors of AC. So factors of negative 10. To equal the B value. We want the factors of negative 10 to add up, in this case, to negative 3. Now, the reason factoring can be hard, especially if the numbers are large, is because there's so many different possibilities. And that's why trial and error can sometimes be trying as well, because you've got to make sure you haven't missed something. And so that's why it's nice to have a system that works. So I'm going to do this the long way, but the more problems you do like this, the better you get at it, and you don't have to start at the beginning. So the list that I would go through, since this is a negative 10 and I want a negative 3, then I'm always going to think, okay, I'm going to start at 1, and 1 times negative 10 is negative 10, right? 1 plus negative 10 is negative 9. So that one, that pair did not work. Then I move up. Okay, what's the next thing that goes into 10 is 2. So 2 and negative 5. 2 times negative 5 is negative 10. 2 plus negative 5 is negative 3. So we found it. That's the combination that works. And so what happens then is, as you're going in the opposite direction of FOIL, these are what your O and your I are going to be. Okay? Remember what happened? Let's look back when I did the multiplication. My O was negative 5V and my I was positive 2V. And the order of those doesn't matter. Okay? So once you know the combination that gives you the correct middle, what you do then is, we're going to rewrite it like this. It's 5V squared plus 2V minus 5V, and what was the last term? Thank you, minus 2. So it's like you're writing out the F, the O, the I, and the F. But then the way you write it as a product is you use factor by grouping. So here we're going to practice factoring by grouping again. So we're looking at these two and these two separately. What comes out from the first two? What's the greatest common factor? V. And that would be 5V plus 2. Remember my hint? My hint was, if it works, what should the factor be? 5V plus 2 again, right? That's what should work. Okay, now what times those is going to give me back negative 5V minus 2? Well, that would be a minus 1. Everybody following?
Wait, we're using the 1
From
To make it negative.
yeah, to get it to be negative. Sometimes it'll be a plus 1 there. You know, if they don't really have anything in common, it's 1 or negative 1 that you want out. That's another thing. It's important to see. But remember what I said, who just asked me that?
Me.
Okay. Remember what I said about my hint? Once you do the first two, you know this is what you want, right? For that second group. So go ahead and write it down and then think, well, does it work? Well, what is it I've pulled out to get these two back? And since they were both negative, it'd be a negative 1. Okay, now that was the first level of GCF. Now do the second level. So 5V plus 2, and then what you have left is the V minus 1. Okay? But if you have never really learned the factoring trinomials very well, practice a lot. So even when you finally get a problem in the homework, I would go ahead and do another one, okay, until you start to feel really confident about using it. Yes, sir?
Can we do other methods?
Well, the other method's just trial and error. So that's just, put parentheses, what should be in the other parentheses.
Oh.
That one to me is so hard to teach somebody how to do. That's why I like having a method that works. Okay? Okay, so you guys doing all right? These periods are so long, I know. Does anybody need to get up and stretch to get some oxygen going to the brain? Okay, and those people at home, they can flip through all these. They can flip through my pauses and everything if they want to. All right. So let's go back now. We've been practicing factoring. We're going to be doing factoring method, but we're going to review just solving simple linear equations first, where you don't need to factor. So let's solve these equations. First of all, well, let me get this one written down, and then I'm going to ask you guys a question. I'm going to ask you a couple of questions, actually. Okay. What does it mean to solve an equation? What does that mean? We were working with expressions just a minute ago. We were not working with equations. Equations have a left side and a right side, correct? There are terms on both sides. But what does it mean to solve an equation? That's how you solve an equation.
You need to move numbers to one side.
Yes, that's how you solve an equation. Once I've solved it, let's say 3 works. What does that mean? What do I mean it works? What is it? The output. I like that you're thinking about functions. You're thinking a little bit ahead for me, okay? But this is an equation. It's got a left side and a right side. So if a number is a solution, what has to be true? What's that?
Both sides.
What does it do with both sides?
They have to be true and they have to equal each other.
She's getting much closer there. When you plug that number in, you get, the outcome on both sides, and so maybe that's what he was getting at. The outcome on both sides is the same, right? Whatever that number is, this is important, y'all. The basics of understanding algebra are so important for you understanding what the method is and why you're doing what you're doing, all right? So when you have found a solution, what have you done? You have found a number that when you plug it in on both sides of the equation, it makes the equation true. Okay? So remember that. That's what it is you're doing here. And now you guys told me how to solve this, so I'm going to go ahead and be quiet now and do what you said. Okay? You've got a minus in front of parentheses, so it needs to be distributed. It's like sometimes this helps a student who has trouble with this sort of thing. There's an understood -1 there. So place it in there if you need to. Okay, but it's 7, and it's -1 times -3b would be plus 3b. But here's the place people will mess up, is right there. -1 times +2 is -2. And I'm going to give you sort of an outline that's important. Just over here a little bit. Okay. This is kind of a general guideline for linear equations, and we're going to be using it with some harder equations where we've got more than one variable. And you don't always have to do all of this, but it's important to think about the flow, okay? What we do is we simplify the sides, we move terms in order to do what you guys said, isolate. Now, sometimes we're going to need to factor. We're not going to see that while we're doing these simple equations with one variable. And then we divide. That's the last thing that we do. So start learning that flow because of the multivariable equations we're going to come across. Simplify, move, factor, divide. And I've told people, come up with your own little phrase, your mnemonic device. Y'all know what a mnemonic device is? Okay. Some men favor divas. How about that? Okay? All right. So that would get you the first letters of all of those, or you think up your own. Okay. So I'm still on the simplifying part. So we've got a 7 minus a 2. So we're going to put those together. That 7 minus 2 is 5. Yes, ma'am.
Why wouldn't, after you distribute a -1, why wouldn't
Okay, that's a good question, and I'm glad you're asking it because a lot of times I don't see what you guys are seeing. That is 7 minus this thing. It isn't a multiplication, and we do have a tendency to want to turn things into something they're not, okay? So part of this is just understanding the math language. What is the math language saying? It's saying 7 minus these terms. That's not going to turn into multiplication. Is that a satisfactory answer?
Yes.
Okay. All right, so 7 minus 2 is 5. Now that side's simplified. The other side was already simplified. So see, I'm finished with that part of the process. The next part is moving terms, and this is what you guys said. We're isolating the variable. So remember, our goal here is to get v equals, in this case, it will just be a number. That's what we're trying to do. So I'm going to add 7v to both sides. That's the move part. I'm moving terms in order to isolate the variable. I don't want the 5 on this side. I need to move it. So I'm going to subtract it from both sides. So when you're simplifying a side, you're not doing the same thing on both sides. The simplifying part, you're not necessarily working with both sides. But when you get to the move part, you've got to do the same thing on both sides. Okay? And so let's see what we get. Okay, we get 10v. This is 0. I'm not going to write that step, but that's why it works. That's plus 0 there. Okay? Yes, that's what I'm saying. Yeah, I'm not a stickler about that step. Okay? And then negative 7v plus 7v is 0, right? And negative 3 and negative 5 is negative 8. Okay? Both of those have a plus 0, but that just adds in another step. Okay, so now, remember, with these, factoring you're not going to have to do, but the divide, we're ready to divide. And so we're going to divide both sides by 10. But we do want to always have simplified versions of our answers, and since 8/10 simplifies, that is negative 4/5. Okay? And I would show you guys how to use your fraction key on the, well, actually, let's go ahead. It's in a video, so then if you need to refer back, you can. Okay, let me, yeah, go ahead.
I did a little bit differently, and I got,
If you got the same answer, you're good.
I got negative 5.
Oh, okay. So you did do something wrong there. I'll have to look. Let me look at it right after class. Okay? All right. I want to show you how you can simplify fractions. Now, if you're going to take trig, do the fractions in your head. The more you practice with fractions this semester, the better you're going to do with your trig, because fractions are going to come in all the time in trig. But everybody else, we got a calculator, so let's just use it, okay? So I'm putting the 8 over 10. I don't need to put the negative. I can remember to put that. And then you go to math, okay? So you put your 8 over 10, hit the math key, and it's already on fraction. And so we hit enter, and then you have to hit enter again, and it will reduce it for you. And it'll always be in improper form if it's a number that could be a mixed number. Okay? Did I do that too quick? Everybody all right with that? That's how you use it. Okay. So, oh, did I have another one in the notes? Let's see.
Yeah.
Okay, let's do another one. Oh, I see what I put in there. Fun. All right, you guys had to do these if you took 1033. You had to do things like this. All right. First of all, we have a denominator. Fractions have a problem because we cannot divide by 0. So we do have to think ahead. Okay, if I came out with a -9, if I plug in -9, I have a denominator that is 0. So if through this process of solving this equation, I come up with -9 as a solution, I'm going to say it doesn't work.
That's my restriction.
That is a restriction. Okay? Whenever you've got a variable in a denominator, you've got restrictions. So you have to think about that ahead of time. And that is really going to be important when we get into domain in a few more lessons. So you may as well start thinking about it now. So, remember my steps. Simplify is first. What looks not simplified here? Fractions. Yuck. I mean, let's get rid of them. So, we're going to simplify our equation by multiplying by the GCF, which is j plus 9. If we multiply the left side and the right side, and in this case I am doing the same thing to both sides. If I multiply both sides by j plus 9, then what I come up with is an equation with no fractions, and it will contain the solution to the original equation as long as there is one. Okay? Whenever you do legitimate things to equations like that, like multiply both sides, then your new equation, it is a new equation, will contain the solution set to the original. So I am going to take the left side and multiply by j plus 9. And the right side by j plus 9. I want y'all to look at this carefully, and probably your writing is even neater than mine, right? But you do need to be careful to recognize that on the right-hand side, we've got a single fraction. Does everybody see that? There's a single fraction. And so multiplying by j plus 9 is really nice because that leaves a 1, okay, in that place. But what have we got left? 1 times 2 over 1. And that's just 2. So see, I got rid of that fraction on the right-hand side. But on the left-hand side, you don't have a single fraction. You have 2 terms that you got to multiply by. You've got to distribute. We did not have to distribute over here. Does everybody recognize the difference? Okay, so what I do is this. Those are going to cancel, right? What does that leave for that first fraction? 3. So let's write it down. However, I will have students that will go like this. Slash, slash. And then they'll write a -1 down here, and that's not right. It's times the j plus 9. Okay? Both of these need to be multiplied by the j plus 9. And the j plus, not only that, the j plus 9 is a group. You're multiplying -1 times the j plus 9. Okay, so you're going to have to distribute there. So that's a real common place to make a mistake. Does anybody have a question right there? Do you recognize what I'm talking about? Yes, ma'am.
Yes, I'm just taught to put the multiple sign near the -1.
Yes.
So it reminds myself, like instead of putting the lily over there, put it where.
You just write it again. Yes. And if you guys need to, write it again. What I try, are you Hope, by the way? Hope, what I try to do is keep things as simple as possible. But if there's a step in there that I'm skipping that you need, do it. I think that's a good plan. Okay? Yeah.
Would that be the same thing as putting -1 over 1 times j plus 9?
Yes. Yeah. We don't really need the 1 over 1. Now, if you wanted to put it over 1 because you're multiplying by this fraction, I understand that. People have an easier time with their fractions when they do that. Yeah.
So I'm confused, like, why did you still after 1 if you have to multiply?
Well, remember, here's your terms, right? Look, do you see my 2 terms originally? You see that it's 2 terms. There's a fraction and there's a -1. You see it? So when I multiply by j plus 9, that has to be multiplied by both terms.
So you can't do 3 minus j plus
Oh, yeah, I'm about to do that. Yeah. Okay. I think you're just ahead of me. Okay, so that's 3 minus j, but it's minus 9. Because it's j plus 9 times negative 1. Yes, right. Is that clear now? Okay. Equals the 2. All right, now 3 minus 9 simplifies. There's a negative in front of that j. And 3 minus 9 is negative 6. So we have simplified all we can. Now we're going to move. We're going to add 6 to both sides. But I've solved it for negative j, not for positive j. So what's the last thing I need to do? Divide, yes. Divide by negative 1. And remember that we started with a restriction, but we're good because that was a negative 9 that we couldn't have, right? So this works. And so what that means is if you carefully plug it in, you should get the right answer. Okay? In fact, let's just do a check. And when you're taking your quiz, I strongly recommend that you check your work because you want to do that on a test, right? So if we go back to the original and I plug in negative 8, let's see if it works. Oops. So I'm plugging in place of the j. And I'm circling back to what we were talking about at the beginning, what a solution to an equation is. Okay? So I'm plugging in negative 8 in place of j. And so we have 3 over 1 minus 1. Over here we have 2 over 1. That's 3 minus 1 equals 2, which is correct. So we found the number that makes that equation true. It's linear. Now I'm going to have you think back to your previous algebra class or intermediate algebra class. If you've got a linear equation, how many solutions could there be? How many? 1 or infinitely many. Good. Or could be that nothing works. Okay? Could be that nothing works. All right, let me go ahead and do a factoring problem. This is where you guys are going to go a little crazy in the homework, okay? Just before you start the factoring process, just take a deep breath. You can do it. You just got to remember the steps that we've been talking about, all right? Especially GCF, because that's where you're going to be asking me a lot of questions probably. I know that we all want to skip over the part that's the why. But if you learn the why behind what you're doing, it makes it so much easier. Did y'all ever see Finding Nemo? Okay. You know the part where Dory and what's the clownfish's name? I can't think of his name. Okay. There's a bunch of jellyfish, and he's trying to get her to not go through the jellyfish, and she's like, yeah, something about jellyfish, and she just runs on. Okay, that's kind of the way I feel sometimes. Like, yeah, she's telling us this is based on this. We don't care. Just show us how to do the problem. I'm going to show you how to do the problem, but understanding it is very important. So this is what factoring method is based on. It is based on something that is true. It's based on this. If you have a product, I'm just putting 2 things, but if it was 6, it's the same thing. If you have a product that is equal to 0, not anything else, 0, then you know something about one of those factors. What is it? Either A has to be 0 to get a 0 product, or B has to be 0 to get a 0 product. Okay? That's what factoring method's based on. If I know that, then it makes it easier for me to understand the method. Because what I'm going to do, if it's not linear, we're going to try factoring method right now. So let's take an example. And the first thing I want you to do is tell me why we know this isn't linear. Negative 6x to the third minus 24 equals negative 6x to the second minus 24x. How do I know that's not linear?
Because there's two that are the same. Right? I'm thinking about something else.
You think about something else? What did somebody else say?
The exponents?
The exponents. Okay, the exponents tell us it's not linear. Can anybody tell me what degree it actually is? Do y'all remember that? It's the highest exponent. So it's 3. Okay, so how many solutions could there be? 3. There could be. Now, notice I said could. There won't necessarily be 3. But it's important to keep that in mind. If it had a 4, how many could there be? 4. All right? Because you might, if you think about that, then you might think, ooh, did I forget something here? Okay, maybe, maybe not. So let's see what happens. I'm going to, because I want my leading term to be positive, I'm going to add 6x cubed to both sides. There's nothing to add it to on this side, so I'm going to kind of just sort of squeeze it over there because they're not the same. And then the minus 24, I'm going to move that. There's nothing to add it to. But the whole point here was I was trying to get 0 on one side. So I was just trying to pick the easier route because I want my leading term to be positive. Did I have to do that? No. If you wanted to get everything on the left, you could. So we have 6x cubed minus 6x squared minus 24x plus 24. What is the first step in all factoring? GCF. Now, there's something different here, though, than when we were just factoring. This is an equation, okay? There are things you're allowed to do with equations that you don't do with expressions. And we're going to talk about it, but we've got to be careful. Okay, so I'm going to factor out 6. The parentheses would be x cubed minus x squared minus 4x plus 4, right? Now, because it's an equation, and make sure you put, this is somewhere I want you to go back to your notes and remember what I said. Don't apply this in a place where it doesn't apply. This is a constant. Does everybody know what a constant is? What does that mean? Just a number, doesn't have a variable attached. If there's a variable, we got to treat this differently. Okay? But since it's an equation, since 6 is a constant, you are allowed to get rid of it. You can divide both sides by 6. Divide the left by 6. What does that give me? 0. If I divide the right-hand side by 6, this is a product of 6 times that factor, so I can just, see, I just get rid of it. Don't do that with x. Don't do that with a variable. But you can, if it's an equation, do that with a constant factor. Simplify your equation. Okay, so then we have x cubed minus x squared minus 4x plus 4. That is 4 terms, guys. Tell me, how do I factor? I'm going to use factoring method to solve this. By grouping. Okay, so we're going to use grouping now. We're looking at these two separate from these two. So I get 0 equals, what should I factor out? To the second, right? X to the second. You want to take the smaller of the exponents when they have a variable in common. And so we would have an x minus 1, right? What was my hint when you're factoring by grouping? Has to be the same. So let's go ahead and write it down. Now, what's going to work? 4, negative 1. Okay, let's just try it. Don't write anything down yet. Does that work? No, because that's negative 1 times x, so that's not quite right. So what do we need? Yes, you need 4, right? Now check it. Negative 4 times x is negative 4x. Negative 4 times negative 1 gives me the positive 4. Okay? Do we have the same factor? Is this going to work? X minus 1, X minus 1. We do. It worked. We checked the, negative 4 is a GCF. So we have X minus 1 times what? X squared minus 4. All right, now, next time we are going to talk about that x squared minus 4, that we have another way to find the solutions to that. But since we're on factoring method, let's just finish up real quick here so I can let you guys go. That is a difference of squares. Factors is x plus 2, x minus 2. Now, I had 1033 students last semester that would get that far and just stop. We're not done, are we?
No.
What does it mean to solve? We got to know the numbers that work. We haven't quite used the factoring property, okay? The zero product property that we talked about. What we do now is we set the factors equal to 0, right? We have a product equals 0. So what do we know? One of those factors would have to be 0 to get the 0 product. And what are the numbers that make the factor 0? Well, these are just linear equations now. That's x equals 1. If you subtract 2, you get x equals negative 2. If you add 2 on this one, you get the last one, which is x equals 2. Done. Now we're done. Because now we know the numbers that would make the equation true. Okay? So you guys get started. Do your how to enter answers homework as soon as possible. And get started on the first real set of homework, which is how to solve equations.